Quarter 3, Week 4, Module 4 for Grade 8. And we will be talking about triangle congruence. It says that two shapes are said to be congruent if they are the same shape and size. Just like in our illustration, the shape may be a reflection of each other or be rotated or translated. Thus, all of the angles and side lengths are the same. Now, how much do you need to know about two triangles to prove that they are really congruent? Let's take a look with this illustration. Suppose two triangles have the same side lengths. Do the triangles have to be congruent? Let's check it out. Yes, because all the angles are determined by the sides. Next question. Would the same be true if two quadrilaterals had the same lengths? And the answer is no. A square and a rhombus can have the same side lengths but are different shapes. Do you agree? Yes, of course. In pairs, determine whether comparing the following pieces of information would be sufficient to show that triangles are congruent. Like in the first illustration, the three sides are the same. Of course, that could be congruent. Now let's check the two sides the same and angle between them. Let's check this one out. Yes, that can still be congruent. How about all the angles the same? Well, not necessarily congruent, but they can be similar. How about letter C? Two angles the same and a side the same. Yes, that is congruent. Letter D. Two sides the same and the angle not between them. Oh, not necessarily congruent. Then we will see why. Now, in order to say that the two triangles are congruent, you must show that all 6 pairs of congruent parts of triangles are said to be congruent. Previously, we learned that if all 6 pairs of corresponding parts, the sides and the angles are congruent, then the triangles are congruent. Let's take a look with the illustrations here. We have triangle ABC and triangle DEF. The side AB is congruent to side DE. Side BC is also congruent to side EF. Side AC is congruent to side DF. Angle A is congruent to angle D. Angle B is congruent to angle E. And angle C is congruent to angle F. These are the 6 corresponding parts. Now, these 6 parts, therefore we could say that triangle ABC is congruent to triangle DEF. Do you really need all those 6 corresponding parts? The answer is no. Why? Because there are postulates and theorems that guarantee the congruence of two triangles by showing only 3 pairs of congruent corresponding parts. Now, let us see how we can verify if two triangles using 2 or 3 pairs of congruent corresponding parts. Let's start with the first one, the Sss Congruence Postulate. Or we could say side-side-side congruence postulate. What does it say? If the 3 sides of one triangle are congruent to the 3 sides of another triangle, then the triangles are congruent, just like in our illustration. Triangle ABC and triangle DEF. There you could say that segment AB is congruent to segment DE, segment BC is congruent to segment EF, segment AC is congruent to segment BF. There you go, the sides. You can therefore conclude that triangle ABC is congruent to triangle DEF. The reason would gonna be the triangles are congruent by SSS. Okay, so let's now have the included angle. What is included angle? It is an angle between two sides. Let's take a look with the first illustration. Triangle IGH. You have there? Where is now our angle which is said to be between two sides? That is congruent sides, rather. You would have in the first illustration, you would have angle HGI, or you could have angle G. That's the included angle. How about in the second illustration? Yes, that is angle GIH, or you could have angle I. And how about in the third illustration? Yes, that's correct. That's angle GHI, or you could have angle H. You could use 3 letters, or you can use 1. The vertex of the angle. You could use that one. And this combo is called side angle side, or just SAS, another kind of postulate. So let's have it more about included angle. Using this illustration, triangle YES, you're going to name the angle or the included angle with the given that YE and segment ES. And the answer would gonna be angle YES or angle E. How about segment ES and segment YS? Well, it's there already. Angle YSA or angle S. Now, how about the third one? That could be angle EYS or angle Y. The other two angles are the non-included angle. So let's take a look. Since we're talking about included angle, let's apply that one here in our next congruence postulate. The side angle side congruence postulate, or shall we say SAS. Now, when do we apply SAS? In proving that two triangles are congruent. It says, if two sides and the included angle of one triangle are congruent to the two sides and the included angle of another triangle, then the triangles are congruent. Just like in our illustration, you can see the included angle. So from the figure, the first figure, triangle ABC, the included angle there is angle E. And the second triangle DEF, the included angle there is angle D. Now, you could say that segment AB is congruent to DE. Angle A, as the included angle, is congruent to angle D. And segment AC is congruent to segment DF. Therefore, you could say triangle ABC is congruent to triangle DEF. The triangles are congruent by SAS. Now, let's now have the included side after we talk about included angle. What about included side? Now, it's here, the side between two angles. Let's take a look with the first illustration. Triangle IGH. So you have there angle I and angle G. It says between two angles. So what is that? And that is, yes, that is segment GI. Okay, how about this second illustration? Well, that is segment HI. In the third illustration, that would be segment GH. This combo is called angle side angle, or just say ASA. Now let's go further. Name the included side with this illustration, triangle YES, YES. So angle Y and angle E, the included side would gonna be, yes, segment YE. How about angle E and angle S? That would be segment ES rather. And angle S and angle Y, you would have SY. Therefore, the other two sides are the non-included sides. Alright? Let's now move on to angle side angle congruence postulate, or we call that one as Asa Congruence Postulate. To use this postulate, if two angles in the included side of one triangle are congruent to the two angles on the included side of another triangle, then the triangles are congruent. So based from our illustration a while back, you have it there, triangle ABC and triangle DEF, where you could say that angle A is congruent to angle D, angle AB is congruent to angle DE, which is our included side. Am I right? Next, we have angle B and angle E is congruent. Therefore, you can conclude that triangle ABC is congruent to triangle DEF. You don't have to identify all the corresponding sides, corresponding angles, those 6. Remember the 6? You don't have to do it that one anymore. You'll just have to make use of this idea. So let's now proceed with the next one. The angle side. Is it possible that you would have the Aas Congruence Postulate? Yes, it says here that if two angles and a non-included side of one triangle are congruent to the corresponding angles and the side of another triangle, then the triangles are congruent. How does it look like? So it says here non-included. So if you would have to say included, that is in between. So meaning it's not included, so it's not in between. So take a look with the illustration number 1, triangle ABC. There you can see that segment BC is the non-included side in that triangle. On the other side, segment EF is the non-included side. So in that way, angle A is congruent to angle D, angle B is congruent to angle E, and segment BC as your non-included side is congruent to the other non-included side on the other triangle, segment EF. And you can conclude that triangle ABC is congruent to triangle DEF, where you could say that triangles are congruent by AAS. Oops, warning, no SSA postulate. There is no such as an SSA postulate or side-side angle. Let's find out here in our illustration. Just observe. Okay, that line. There you go, the other line, which is the other side. Oh, take a look with that one. They are not on the same position. So the triangles are not congruent. Let's furthermore explain with this illustration. Take a look with the whole picture of our triangle. You have there triangle ABD and triangle, the bigger triangle, ABC, or you could have it there. Yes, look at it. Are they on the same figure, the same size? Well, of course, no. And that's the reason why there is no such SSA postulate. But SSA does work in one situation. That is if we know that the two triangles are right triangles. Just like in our illustration. We call this one as the Xyl Congruence Theorem. Or shall we say, hypotenuse leg. So these are good for right triangle. So for the HYL, you would have it there. If the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. So take a look with our illustration. Triangle LGH and triangle BCA. Segment AB is congruent to segment HL. Segment CB is congruent to segment GL. and angle C rather and angle G are right angles. So, where is, by the way, our hypotenuse there? In the first illustration, triangle LGH. The hypotenuse there is segment LH. On the other triangle, that is segment AB. What is hypotenuse, by the way? Hypotenuse is the side opposite to your right angle. Okay? So, those sides which are not opposite to your right angle, we simply call them as your legs. Okay? In that way, yes, you have it there, the right triangle, the legs, and the hypotenuse. In that way, triangle ABC is congruent to triangle HLG. The triangles are congruent by HYL. Now, aside from Xyl Congruence Theorem, we will also have the Xya Congruence Theorem. What does it mean? If the hypotenuse and an acute angle of one right triangle are congruent to the corresponding hypotenuse and an acute angle of another right triangle, then the triangles are congruent. Let's take a look with our illustration here. Triangle LGH and triangle BCA. Segment AB is congruent to segment HL. Angle B is congruent to angle L. Angle C and angle G are right angles. In that way, we were able to prove that triangle ABC is congruent to triangle HLG. The triangles are congruent by HYA. Now, we could also have the LL Congruence Theorem, or shall we say, Leg Congruence Theorem. It says that if the legs of one right triangle are congruent to the legs of another right triangle, then the triangles are congruent. So right here in our illustration, segment CB is congruent to segment GL. And segment AC is congruent to segment HG. And angle C and angle G are right angles. In that way, these two triangles, or triangle ABC and triangle HLG, are congruent by LL, Congruence Theorem. Now, we also have the leg angle congruence theorem, or shall we say LA, not Las Aguadas, but LA. If the leg and an acute angle of one right triangle are congruent to the leg and an acute angle of another right triangle, then the triangles are congruent. So take a look with the illustration. Segment AC is congruent to segment HG. Angle B is congruent to angle L. Angle C and angle G are right angles. In that way, triangle ABC is congruent to triangle HLG by LA Congruence Theorem. Now let's check. How far have you learned from this video? Okay, let's have letter A. Let's try to answer just simply by clicking this unknown button. Alright, so let's have letter A. What's your answer? Yes, and that is SAS. Two sides and the included angle. How about the second? What's your guess? You are right. That is AAS. Two angles and the non-included side. How about letter C? Very good. That's correct. Three sides, or shall we say the SSS. And we have letter D. HYL. There is a right angle, hypotenuse, and the leg. Or simply we call that one as the side. Next, letter E. Alright, that is LL. Two legs. And letter F. LA, a leg and an angle. For letter G, you have ASA, two angles and the included side. And lastly, we have, very good, that is HYA, right angle, hypotenuse and an acute angle. So let's have this add-on exercise. Let's take a look with that illustration. Yes, very good, that is SAS. How about this? Yes, ASA. How about this? Oh, SSA. You remember? There is no such SSA. Not enough information. Yes, that's correct. AAS or SAA could be. Now let us apply triangle congruence in this problem. In the diagram, triangle ABC is congruent to triangle BTU. Just leave it there. There is no such a symbol there in the BTU. It's okay. We are asked to find the indicated measure. Okay, let's take a look with our illustrations. You have there triangle ABC and triangle BTU. With angle A is 50 degrees and angle C is 20 degrees and segment BT is 15 meters. Let's find out the measure of angle B using these two illustrations. Okay, so always remember in a triangle, the totality measures of the angles of a triangle is equal to 180 degrees. There's no it's not greater than 180 nor less than 180, but exactly 180 degrees. Now, if you're going to take a look with our first illustration, we're looking for the measure of angle B. And that is lacking there. So we just simply have 50 plus 70 plus angle B is equal to 180 degrees for you to solve for B. So by simplifying, you would have 50 plus 70, that will give you 120. Then you will use the subtraction property of equality so that you will be able to have 180 minus 120 degrees will give you 60 degrees. So again, the measure of angle B is 60 degrees. Now let's proceed to problem letter B rather. So we are asked to find how long is segment AB. Okay, so let's click and there you go. Segment AB is congruent to segment BT. Remember, corresponding parts of a triangle. So right there, segment AB will be equal to segment BT. That's not BY, it's BT. So BT there is 15 meters. So whatever would be the measure of segment BT will also be the measure of segment AB. And that's why AB therefore is also 15 meters. Clear. Next up we have letter C. Measure of angle T. To find the measure of angle T, always have this idea of the corresponding angles. The corresponding angle for angle T in the first illustration is angle B. And we already have the value or the measure of angle B, which is 60. Therefore, measure of angle T will also have the measure as the measure of angle B, which is 60. Is that clear? Next, how about letter D? Yes, the same thing. Angle B correspond to angle A. So kumbaga, they are just the same. So whatever would be the measure of angle B will also be the measure of angle A, and that is 50 degrees. Next, we are asked to find the value of x in these two illustrations. Alright, so in the first illustration, the measure of the angle is 120 degrees and the second angle is 20 degrees. And if you are going to take a look with the second illustration, that is angle 2x plus 4 degrees. That means that angle there is just the angle lacking in the first illustration. And take note, in a triangle, the totality measures of the angles is always equal to 180 degrees. So, in that way, we can solve for x by adding all those angles. That would be 120 degrees plus 20 degrees plus the lacking angle from the other triangle, which is 2x plus 4, because they are corresponding angles. There you go, you would have equal to 180 degrees. Okay? By simplifying, you would have 120 degrees plus 20 degrees plus 2x plus 4. You will have 144 plus 2x is equal to 180. So we're looking for the value of your x. You will transfer, or you will apply subtraction property of equality. The 144 will be transferred on the other side. That would give you 180 minus 144. Simplifying that one, x value will be 18 as the value. Clear? Next up, we have the value of our x in the second illustration. So in the first illustration, you have there the 35 degrees, and the second illustration is 5x degrees. And that 5x there can be filled out to the first illustration since we assume that these two triangles are congruent. Remember, they are right angles. So the symbol there representing the right angle, which measures 90 degrees. So to find x, you would have 90 plus, so you have 90 plus 35 plus 5x equals 180. So 125 plus 5x is equal to 180 degrees. So we're looking for the value of our x. 125 will be transferred on the other side. That will give you 180 minus 125. Then, simplifying, you would have x is equal to 11. So this time, it's your time to answer the activity. So you will answer this one in a short bond paper, long or short could be. Then you will submit it on the following Monday. Okay? So, have a copy of it. Okay, we have. So thank you so much for listening. God bless us all.